Finding inverse functions, a simple technique. A function f of x and a function f inverse of x are inverses of each other if and only if the function is a one-to-one function and the composite function f with f inverse of x and the composite function f inverse with f of x equal x. So to have a function, we must pass the vertical line test, which means we look to see if the function has two y values for any x value. The simple way of doing this is to graph the function and take a piece of paper, which has a very straight edge, and pass it slowly over the function, making sure one point appears at a time. A one-to-one function must also pass the horizontal line test because the inverse function must also be a function. Okay, the method of finding a pair of inverse functions. First, confirm the function is a one-to-one function. This is important because the domain of the function becomes the range of the inverse, and the inverse function's domain becomes the range of the function. So a function and its inverse swap ranges and domains. Write the expression using y in place of x. Write a new equation where x and y replace each other because the domain of one becomes the range of the other. Now we solve the new expression for y, and we replace that y with f inverse, and we found our inverse. Example, find the inverse if it exists of f of x equals 2x cubed plus 1. First thing we do is write y equals 2x cubed plus 1. Now we replace y with x and x with y, and we get x equals 2y cubed plus 1. Now we have to solve for y, so we get 2y cubed on one side, and we have x minus 1 on the other. Continuing, we divide by 2, and we get y cubed equals x minus 1 over 2. And finally, we find our inverse, which is y equals the cube root of x minus 1 over 2. And we replace the y back with f inverse. You can check with the composite of f inverse if you like, but this is the actual inverse. A function and its inverse have graphs that are reflections of each other about the line y equals x. While we can go through the procedure even checking both the vertical and horizontal line tests, we must think about the answer. Here I have another example. F of x equals the square root of x. Passes both the vertical and horizontal line tests. It appears that f inverse is x squared. But f inverse equals x squared must be restricted to the domain from 0 to infinity, including 0, to have the proper reflection above the line y equals x. The problem is x squared does not pass the vertical line test. So here, since the square root is only defined for positive values and 0, the inverse must be restricted